All right, picking up where we were before, we have we're trying to verify some trig identities, okay? So hopefully you had a chance to catch up on the notes there. We're trying to add a fraction and a fraction together and somehow end up with cosecant x as our answer. So first thing let's do is let's add these two fractions together. The common denominator, since these two are unlike, will be sine times 1 plus cosine. That's our common denominator. So we take sine times sine, and we get sine squared x. Plus sign in the middle, we have cosine x times 1 plus cosine x. This times this. And in the denominator, we have sine x over 1 plus cosine x. Okay, so looking at this, we do have a little bit of math to clean up. Let's go ahead and distribute. Okay, and so we have sine squared x plus cosine x plus cosine squared x all over sine x times 1 plus cosine x. Okay, I'll give you a second and let you catch up and digest there. Yeah. Okay, once you go ahead and try that, the next example that I want you to try is kind of the same as the first one that we did. Let's take 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha and show that that's equal to 2 secant squared alpha. Okay. Then we're going to come down and we're going to do 2 more problems. Example 4. This one's kind of neat. Okay, example 4. What do you get when you take the quantity tangent squared x plus 1 times cosine squared x minus 1? Can you show that this is equal to negative tangent squared x? Okay? Can you do that? That's a good question. All right, and then finally the last example for this section that we'll go through. Can you show that tangent x plus cotangent x is equal to secant x cosecant x? How in the world do we get a quantity that has a plus sign to equal this multiplication? What in the world? Craziness. Okay, so don't forget, work with one side at a time. Substitute with identities. Factor, add fractions, square, perform the operation, whatever. Excuse me, if that doesn't work, substitute, try converting all sines and cosines, and finally try something. Okay, so let's go ahead and let's work example 2. Okay, so when you look at this, we have a left side and a right side. Now remember, I can't subtract sine squared theta from both sides. Okay, I have to show that the left side is equal to the right side. Okay, thanks for hanging in with me, guys. All right, so is there a substitution that we can make for secant squared theta minus 1? Go to your sheet. See if I can find a sheet. And I can't. Well, let's see. Here's what we have from a couple of days ago. But that doesn't give us the one from the last section, okay? The Pythagoreans here are only sine squared plus cosine squared equals 1. Okay? So I'm looking for something that says secant, that relates secant squared minus 1 to something else. Okay? Well, here's secant squared. And if I move this 1 to the other side, then this gives me a variation. I have secant squared x minus 1 would be equal to tangent squared x. This is a very common substitution. Okay, so anytime I see secant squared theta or x minus 1, I can put in tangent squared theta or x, whatever the variable is. Okay? So let's take that, let's make a substitution. Okay? Alright, so secant squared theta minus 1 is equal to tangent squared theta. Okay, let's see if we can manipulate that a little bit and give you a chance to digest. Okay, hopefully you said, hey, you know what? I'm going to make a substitution for tangent squared. I'm going to get everything here in terms of sine and cosine. We were going to do that at some point anyway. Let's do it now. So this gives us sine squared theta over cosine squared theta. Remember? That's what tangent is equal to. And we know that secant is what? It's 1 over cosine. And if it's squared, it's squared. So we have sine squared theta over cosine squared theta over 1 over cosine squared theta. Now, let's go ahead and let's do our algebra. We're going to invert and multiply. So we're going to multiply by cosine squared theta over 1. We're going to flip this. What happens to the cosines? Well, guess what? They divide out, which leaves us just with sine squared theta. Okay? Alright, let's go on to the next one. Alright, so here we go. So I see a fraction plus a fraction. You know what I'm going to do? I'm going to add these babies together. So that's 1 plus sine alpha plus 1 times 1 minus sine alpha. Of course, if those were anything other than 1s, I'd have to distribute over the product. The product, this is the difference of squares. This would be 1 minus sine squared alpha, difference of squares. Do you recognize this? Do you recognize that? Let's clean up the numerator. 1 plus 1 is 2. Wow. You know, there's a lot of gold in this video, but I don't think I can top that. 1 plus 1 is indeed 2. Negative sine alpha and sine alpha, they cancel out. Okay? And there's one more substitution to make. It's for 1 minus sine squared alpha. Look at your Pythagorean identities. 1 minus sine squared is equal to cosine squared. Oops, sorry. We're working with alpha today. Look at that. Okay. Now, if this were a whiteboard, yeah, I could just scribble that out and go right on. But yeah, okay. All right. Now, this is then 2 times 1 over cosine squared alpha. What's 1 over cosine squared? You got it. Secant squared. So 2 secant squared alpha. Check. All right. All right. Let's go down to this next one. Okay. This looks a little bit uglier, but I promise you, we can make some pretty nice substitutions. We can look at the Pythagoreans. Tangent squared plus 1, well, guys, that is directly secant squared. And cosine squared minus 1, we talked about the other day, that is negative sine squared. Okay? 2 very simple substitutions, but here's what I want you to look at. Again, let's get everything in terms of sine and cosine. So secant squared, we know, becomes 1 over cosine squared. So we manipulate a little bit of algebra, top times top, bottom times the bottom. We get negative sine squared x over cosine squared x, which is what? Negative tangent squared x. That's what we were looking for. Now, I know, guys, that I make that look easy, and believe me, I don't expect you to get this on the first time, especially given the fact that we can't be interactive. Please email me with any questions you may have. You know, I miss you guys. I miss our interaction. So let's go ahead and let's crank out this last example. and then we'll look at section 3 maybe. Maybe there are a couple more examples. Maybe I'll come up with something at the beginning of the next video. Okay? All right, so let's go ahead and let's do this last one. I'm going to get everything into terms of sine and cosine because tangent, cotangent, secant, cosecant is very convoluted. Okay, so let's simplify this. I know that tangent is sine over cosine. And I know that cotangent is cosine over sine. I know that secant is 1 over cosine, and cosecant is 1 over sine. So getting everything into terms of sine and cosine puts us at this point. Now, we have to work each side independently. You can either work the left side until it equals the right side. You can work the right side until it equals the left side, or you can work them both until they equal each other. Maybe that's the way to go here. I'm not sure. But we've already worked the left side a little bit, and we've already worked the right side a little bit. So let's just go ahead and let's see. I see a fraction plus a fraction. Add them. All right, so let's add them. Sine times sine is sine squared. If it's an x, it's an x. Plus cosine x times cosine x is cosine squared x over cosine x times sine x. Guys, what's sine x plus what's sine squared plus cosine squared? You got it. Hopefully you recognize that. Guess what? It's 1. And we turned it into 1 over cosine x sine x equals, and guess what? It's already on the other side. There's your last example. I'll try and come up with a couple more as a warm-up on the next section. Okay? Go ahead, email me with questions, please, and we'll talk.